For problems 1 through 4, you have to classify angles. You need to know the 4 classifications. Acute angles are less than 90 degrees. Right angles are exactly 90 degrees and they will be marked with this mark. Obtuse angles are more than 90 degrees. Straight angles are exactly 180 degrees and they are straight angles. In problem number 3, we have an angle that is less than 90 degrees, so that would be acute. That was problem number 1. In problem number 2, we have exactly a straight line, so that would be a straight angle because it's 180 degrees. In problem number 1, we have 76, which is less than 90, so that would be acute. In problem 4, we have 177 degrees, which is more than 90, so that would be obtuse. In problem number 5, we have line segment QS. The total length is 14. That's how I got it to equal 14. So I have x plus 3x plus 2 equals 14. I am going to combine like terms, so I'm going to go x plus 3x. That's how I got 4x. And I have plus 2. So I want to get rid of that 2 because I want x by itself, so I'm going to go minus 2 from both sides. So I got 4x equals 12. I am going to divide each side by 4, so I get x equals 3. To check to see if this is correct, I can plug it back into the equation. So I get 3, and then I get 3 times 3 is 9, plus 2. Add those all together, and I get 14. In problem number 6, I have line segment TV. TV, the whole line segment, equals x plus 24. I have 2x plus 21 from right here, plus 12. So plus 12. I'm going to combine like terms. 21 plus 12 is 33. I want to get x by itself, so I'm going to go minus 33 from both sides. So I end up with 2x equals x minus 9. I'm going to minus x from both sides. I get x equals negative 9. If I plug in x equals negative 9, you'll see that is correct. In problem number 7, I have segment RT. That segment equals 19. That's how I got 19. So I'm going to take the parts. X minus 3 plus 2x minus 11. That's where that came from. I am going to combine like terms. X plus 2x, that's how I got 3x. And then I have minus 3 minus 11, that's how I got minus 14. I want to get x by itself, so I'm going to add 14. So I get 3x equals 33. I am going to divide by 3 to get x by itself, so I get x equals 11. You can go back and check that by plugging the 11 in, and you'll see it equals 19. In problem number 8, I have line segment LN. That total length is 15, so I'm going to make it equal 15. I am going to go take the parts. 2x plus 30, 21 plus x. So I'm going to combine like terms. 2x plus x equals 3x. 30 plus 21 is 51. I want to get x by itself, so I'm going to go minus 51 from both sides. So I got 3x equals negative 36. Get x by itself, divide by 3, so I got x equals negative 12. In problem number 9, I am looking for the midpoints of a line segment. The midpoint, if you look at the equation, is really the averages of x and it's the average of y. So first thing I'm going to do, I am going to label my points. So x1, y1, x2, y2. To find the average of my x's, I am going to go negative 9 plus 1 divided by 2. So that gives me 8. Negative 8 divided by 2, that's how I got negative 4. I'm going to take my y's. Negative 5 minus negative 6 divided by 2. So I got negative 11 halves. Improper fractions are fine. Number 10, I'm going to find the midpoints. First thing I'm going to do, label my x's, x1, y1, x2, y2. I am finding the average of the x's and average of the y's. So I'm going to take my first x, 1 plus 0, divided by 2 is half. I'm going to do the next one. I'm going to take my y's. 9 minus 3 divided by 2. So that gives me 6. So that gives me 3. In number 10, notice I have a negative here. So instead of adding, I really went plus negative 3, which is the same as subtracting. On number 11, first thing I do is label my points. x1, y1, x2, y2. So I want to find my averages of my x's. So I'm going to go my x, so I have 4 plus negative 1 divided by 2. That's how I got 3 halves. I went negative 7 plus 7 divided by 2 equals 0 over 2. Notice in problem 9 and 10, I'm doing it different than problem 11 because it doesn't matter what order I put the x's in because I'm just finding an average. It doesn't matter what order I put in the y in, I'm just finding the average. So number 12, first label your x's and y's. So I am going to take 8 plus negative 9 divided by 2. So that gives me negative 1 divided by 2. That's how I got negative half. And then I am going to take my y's. 6 plus 2 is 8. Divided by 2 is 4. So that's how I got that answer. Doesn't matter which way you put the x and y's. In problem number 13, I'm given a line segment on a graph. So first thing I need to do is figure out what the ordered pairs are. I read my x-axis first. So my first point, I go left 2, down 1. That's how I got negative 2, negative 1. My next point, I went right 2, down 2. That's how I got 2, negative 2. I am going to label my points, x1, y1, and do the same thing for the other pair. I am going to do the distance formula. So first I'm going to look at my picture. So if it was a straight line, I could say it was 1, 2, 3, 4. So I know the answer is going to be more than 4 because this is on a slope. It's not a horizontal line. So I know it's more than 4. So I am going to use the distance formula. So I'm going to do the difference of x's. So 2 minus negative 2, which is plus 2. 2 plus 2 is 4 squared. Squaring gets rid of the negative, so that's how I got 4 squared. 4 times 4 is 16. Now I'm going to do my y values. Negative 2 minus negative 1, which is negative 2 plus 1. So I get negative 1 squared, which is 1. So the square root of 16 is 4 plus 1 more is a little more than 4 like we said at the beginning. So I'm going to write that answer as a radical square root of 17. In problem 14, first I'm going to label my points. So I am going to go left 5, down 4 is that point. So there's my ordered pair. I'm going to go right 3, down 1, there's my second ordered pair. So I'm going to label my points, x1, y1, and do the same thing for the other one. So first I'm going to figure out the distance from here to here is 5, from here to here is 3. So this is on the slope. It's not a horizontal line. So this distance is 8. Because the distance formula is based on Pythagorean theorem, I know this distance must be longer than 8. So when I calculate it, I got to get a number longer than 8. So I'm going to find the difference of x's. So I'm going to start with 3 minus negative 5. So that a minus is plus. 3 plus 5, 8. 8 squared is 64. I'll do the same thing for my y's. Negative 1 minus negative 4. Minus is plus. Negative 1 plus 4 is 3. 3 squared is 9. So I get 64 and 9 squared is 73, which square root of 64 is 8. So this is a little more than 8. In problem 15, they just give us the ordered pair, so I'm going to go ahead and label them. I'm going to find the difference of my y values and my x values. I'm going to start with x. Negative 2 minus 3. Minus is plus. So negative 2 plus 3 is 1. Squared is 1. And I'm going to do the same thing for my y's. So I'm going to start with 3 minus 2 is 1. And I'm going to square it. So I end up with 1 plus 1 square root of 2. In problem 16, they give us ordered pairs, so I'm going to label them. I'm going to find the difference of my x's. 0 minus negative 1, minus is plus. So 1 squared is 1. And I'm going to do my y's. 0 minus negative 3, minus is plus. So I get 3 squared is 9. 1 plus 9 is the square root of 10.